Hello everyone, good evening. Zainab and Neha,
Good evening.
good evening. How are you all?
And how are you?
Okay, sorry, today I have some network issue. Okay, so connectivity is unstable today. So, okay, so Sanidhi has also joined. Hi Sanidhi, how are you?
Good, ma'am. How are you?
I'm good. Okay, so if there's any problem in my voice, okay, so just please let me know because I have some connection issue today. And today we have to finish this chapter. Anyhow, we have to finish this and we have to start the equilibrium chapter next. Okay, so let me check with the team whether Aisha and one more student will join our batch today, Aman. Okay, so let me check with the team whether they will join or not. We'll start the session. Okay, so let's start the session. Already 10 minutes, okay. So let's not wait for a bit more for them. Okay, so the next topic is, we have already discussed these topics, phase transition, okay, irreversible processes and reversible process. Okay, now write down the next heading, second law of thermodynamics. Second law of thermodynamics. Okay, now the question is, what is second law of thermodynamics? Okay, so for second law, according to second law of thermodynamics, okay, see. So what does second law of thermodynamics say? So it states that whenever there is a spontaneous reaction, whenever there is a spontaneous process, so it is always accompanied by an increase in total entropy of the universe. Total entropy of the universe will increase in the spontaneous process. Okay, according to the second law of thermodynamics. Whenever there is a process and that process is a spontaneous. Okay, so a spontaneous reaction or process always accompanied by a increase in total entropy of the universe. Okay, and what is universe? So universe means system plus surrounding. Okay, universe की बात कर रहे हैं हम, it means system plus surroundings की बात हो रही है. Okay, so according to second law of thermodynamics, write down, it states that first point, whenever spontaneous it is always accompanied by an increase in total entropy universe. Okay, and in this statement, what does universe means? Universe means the system and the surrounding. Okay, so you can write down system and surrounding combinedly known as universe. Thus, delta S of universe, entropy change of universe is equals to entropy of system plus entropy of surrounding, according to second law of thermodynamics. So that's the equation. So that's the first point. What is the second point? So secondly, it states that it is impossible to take heat from a hotter reservoir. Okay, it is impossible to take heat from a hotter reservoir or object, you can write hotter object, and completely convert into work, into work by a cyclic process. By a cyclic process. without transferring a part of heat, a part of heat to a cooler reservoir, cooler system of reservoir. Okay, and this statement is this statement basically second law of thermodynamics has two statements. Okay, first statement is delta entropy of universe is equals to the entropy of system plus the entropy of surrounding. That's the first statement according to the second law of thermodynamics. And this is the second step or second point you can say. Second point says that according to the second law of thermodynamics, it is impossible to transfer a heat or take out heat from a hotter reservoir. Take out heat from a hotter reservoir and completely convert the heat energy into work by a cyclic process without transferring a part of heat to a cooler reservoir. So it is always compulsory to transfer the heat. Okay, transfer the heat to a hotter to cooler. We know that heat transfer कैसे होता है unidirectional. Okay, from hotter reservoir to cooler reservoir. If you don't add the cooler reservoir, then heat transfer will not take place. It is impossible to take heat or transfer the heat from hotter reservoir to hotter reservoir. Hot से hotter में transfer कभी नहीं होगा. Okay, it is always required cooler reservoir. So hotter to cooler reservoir, always the heat will transform. Okay, so that is impossible to take heat from a hotter reservoir and completely convert that heat energy into work. Okay, by a cyclic process. अगर आप कि cyclic processes के through you can take heat from a hotter reservoir and completely convert that heat energy to a useful work. So that is impossible. Okay, so you need a cooler reservoir, okay, and you have to transfer some amount of heat energy to a cooler reservoir. Okay, so this statement is known as Kelvin's statement. What is this? This statement is known as Kelvin's statement. Okay, and this above statement ko you can write down in a simplified language. This above statement you can write in a simplified language. It can be stated as for a spontaneous reaction. Okay, for a spontaneous process, for a spontaneous process in an isolated system. Okay, we're just taking an isolated system. This is only for an isolated system. For an isolated system, the change in entropy is positive. Entropy is positive. Okay, so you can learn the simplified language. Okay, first statement क्या कहता है? According to second law of thermodynamics, it states that whenever for a spontaneous process, the total energy of the universe is equals to the sum of the entropy of a system and the entropy of a surrounding. So that's the first point of the second thermodynamics. And the second point states that for a spontaneous process in an isolated system, the change in entropy is always positive. So these are the 2 points you have to keep in your mind. Clear, everyone?
Yeah.
Yes.
Okay, so please write it down quickly. Second law of thermodynamics. Written, everyone?
Yes, ma'am.
Okay, so the next topic is Gibbs energy. Okay, so what is Gibbs energy? So Gibbs energy basically it is denoted by capital G, denoted by capital G, or delta G is the change in Gibbs energy. Change in Gibbs energy. Okay, now let's understand. It is also known as free energy or Gibbs free energy. Gibbs energy, or you can call it as a Gibbs free energy or only free energy. Okay, now let's understand this term. What is Gibbs energy? It is important. So Gibbs energy is basically energy of a system which can be converted in the form of useful work. Energy of a system, you can write down the definition first. What is Gibbs free energy? Or you can write down the maximum amount of energy available to a system during a process that can be converted into useful work into useful work. Free energy or Gibbs free energy, or you can only call it as a Gibbs energy. Gibbs energy, and it is denoted by capital G. Okay, now let's understand this. And yeah, one more thing. Gibbs energy, it is not possible to convert all internal energy to a useful work. What I said, it is impossible to convert all internal energy to a useful work. Like how? If I suppose, if I take an example of biological system, suppose like our human being, हम human beings के example ले ले. Okay, if I say, like I have 10,000 kilojoule of energy. I have total energy मेरे पास कितना है 10,000 kilojoule. Okay, and I told you just go and run. Okay, and just use this total energy into basically to convert this energy, total energy into a useful work. Okay, I just ask you, just convert your energy to a useful work. You have 10,000 kilojoule energy, total energy. Okay, so what you did, you guys just started running. Okay, just one round, two round, three round, four round, etc. And after some rounds, you come to me and you said, "Ma'am, ab nahi ho payega." Okay, now I can't do that. I'm tired. Now I'm tired. I have no energy. Okay, I have no energy, but you have 10,000 energy, 10,000 kilojoule of energy. Okay, but you said you have no energy after running and running and running. Okay, after running, आप अगर मेरे पास आते हो and you just said I'm just tired, अब मुझसे नहीं हो पाएगा. You are tired now. You have no energy. So, but it is incorrect. You have energy. You have energy. Why? Because you are speaking. You are talking to me. You are hearing. You are responding. राइट आपके इंटरनल ऑर्गन्स वर्क कर रहे हैं इंटरनल प्रोसेसेस हो रहे हैं सर्कुलेशन हो रहा है एक्सेट्रा रेस्पिरेशन हो रहा है सो यू हैव एनर्जी ओके बट यू सेड दैट you are tired अब नहीं हो पाएगा, you are tired and you have no energy. So it is incorrect, right? So that's why I said it is impossible to convert all your energy to a useful work. आप पूरी एनर्जी कंज्यूम नहीं कर सकते and you can't convert all your energy to a useful. Okay, understood or not?
Yeah, ma'am.
Yeah, so that's the Gibbs energy. Gibbs energy basically energy of a system which can be converted into a form of useful work only. Okay, and this is known as a free energy or Gibbs free energy. And write down, it is not possible to to convert all your internal energy to a useful work, to a useful work. Okay. Okay, so that is your Gibbs free energy, and it is a extensive property. Gibbs free energy is again a extensive property, just like your entropy, extensive property, and a state function. It is also a state function. It only depends on a initial or final state of a process of a reaction. Okay, and Gibbs equation basically Gibbs free energy का equation होता है, write down, Gibbs equation or Gibbs formula is delta G. Okay, the change in Gibbs free energy is equals to the change in enthalpy minus T del S. This is very important formula. Delta G equals to your delta H minus T del S. Okay, so what is delta H, delta G over here? So delta is G is your change in free energy. And delta H is your enthalpy change. This is your enthalpy change. And T, you know very well, T is your temperature, and your delta S is your change in entropy. Change in entropy. So that is the formula. Okay, suppose let's take this formula as first. Let's suppose it's first equation. And what is the SI unit? We can add here. The SI unit of Gibbs free energy is, I'm writing here, SI unit, because it's again an energy. So what will be the SI unit? It's joule. Okay. So SI unit of Gibbs free energy is joule because it's again an energy, and energy ka unit is joule. Okay, so let's suppose this is the first equation. Now see, as we know that, write down, know that, as we know, according to the second law of thermodynamics, you know very well, the entropy change of universe is equals to the entropy change of system plus your surrounding. That is then right, according to second law of thermodynamics. Okay, now here you know very well delta at delta surrounding. Okay, so you know हमने कल formula देखा था एक in the last class. The delta H surrounding S surrounding will be, this is surrounding, will be minus Q upon T. Minus Q upon your T. Okay, so the heat change, okay, per unit temperature. Heat change per unit temperature, and it will be minus, okay, because system surrounding की बात हो रही है, so it is basically the work is done. Okay, so the heat is being evolved from a system to the surrounding. Heat is being transferred from system to the surrounding. So in this case, your Q will be negative. Okay, Q will be negative. So delta S of surrounding will be minus Q upon T. So you can substitute in this equation. So when you substitute this, so you will get S of universe, says your universe, is equals to your delta S of system minus, what it will be? Let's substitute this formula, minus Q upon T. And what is this Q? The heat of the system. Okay, heat of system, basically, this is heat of system will be negative for your delta S. Delta S of surrounding will be minus Q of system upon this one. Okay, of this one. So here you will not write a heat evolve kahan se ho- heat is being transferred from the system to the surrounding. So in this case, your heat of system will be negative here. Okay, surrounding will be negative of the heat of surrounding will be the negative of the heat of your system. Okay, that's what I have been used. So let's substitute this formula. Now delta S of universe will be, let's take this as a LCM. So it will be T del S of a system minus Q of system. Now, can we substitute this heat by enthalpy change? Heat is equals to the enthalpy change. We have learned this earlier, right? So can we substitute this in this equation? Yes, we can. So Q of a system, I'm just substituting it by a delta H of system. Delta H of system, you can write here. So delta H of system is equals to Q of system. So that's why I've written this. Now T-co, let's take this here on the left side. So it will be T del S of universe is equals to T del S of system minus your enthalpy change of the system. Okay, suppose let it be second equation. Let it be second equation. This is the second equation, and this was the first equation. Delta G equals to delta H minus T del S. Is it clear till here? Neha, Zainab, and Sannidhi?
Yeah, ma'am. Yes, ma'am.
Okay, now see, if you compare these two equations, suppose if I write this equation, मैं इसे ऐसे लिखती हूँ, just a second. Don't suppose this as a, suppose T del S of universe is equals to, okay, let's take this minus here, minus del S of system plus T del S of system. Okay, so let's minus sign as common. So it will be delta H of system, and minus plus will get minus P delta S of system, delta S of system. P del S, which is equals to the temperature into your entropy change of your universe. This is your universe. Now, let it be this equation go up second equation now. Let this equation be second equation. Now compare this with first equation. Okay, this is your first equation, delta G equals to delta H minus T delta S. Okay, now when you compare this equation, so you will get to know this delta H, right side, okay, right side of the equation is same. Okay, when the LHS is same, so RHS will also be same. So this negative sign ये कहाँ आ जाएगा? इस side. Negative sign आप इस side ला सकते हो. So it will be minus T del S of universe, okay, which is equals to the delta G. When you compare equation number first and second, okay, write down comparing first and second equation, you will get delta G is equals to minus. This is minus sign will come over here, okay, because the right side में क्या है? Negative, positive, positive. This is your plus delta H minus T del S. Okay, so this will be this part. This is the part. So this is common in both the equations. So it will be delta G is equals to minus T del S, okay, of universe, of universe. So this is the equation we get. Delta H is equals to minus T del S, minus T del S. Okay, this is again important. Now for irreversible type of reaction, irreversible. Okay, what is the irreversible type of reaction? Spontaneous or non-spontaneous process? Yes, Zainab. Irreversible process is spontaneous or non-spontaneous?
Spontaneous.
Yes, it's a spontaneous. Okay, so it's for irreversible or spontaneous process. Okay, tell me for a spontaneous process, the entropy change, what is the entropy change? Positive or negative? Sanidhi, for a spontaneous process, what is the sign convention of your entropy change? Delta S. Positive
For
or negative?
negative? No. Be positive.
Positive one. Okay, I have discussed in the previous class. Generally, we just take for the spontaneous process, delta S is positive. Generally, it is not true for all the cases. Okay, so generally for the spontaneous process, delta S is positive. Okay, and entropy basically increases. When the entropy increases, delta S की value क्या होती है? Positive. And for the non-spontaneous, entropy decreases, so the delta S value will be negative. Okay, so but this is not true for all the cases. So for irreversible process, we have discussed that delta S of universe की बात हो रही है, it is greater than zero, means positive. Okay, it is greater than zero, means positive. So you can see this equation. Just observe this equation. So delta G, what is the relationship between delta G and entropy change? So just a inverse relation. Here you can see the negative sign. Okay, negative sign means if delta H increases or delta G की value positive होगी, so delta S value will be negative. From this equation, you know that if delta G value is positive, then delta S value will be negative according to this equation. So for the suppose if for the irreversible or spontaneous process, delta S value entropy change, we know that it is greater than zero, means positive होता है. Greater than zero means positive होता है. So what will be the delta G? Just a negative? It will be negative because यहाँ पे क्या है symbol ये just opposite होगा. So here when the entropy change is greater than zero means positive होगा for the spontaneous process, then your delta G, okay, your change in Gibbs free energy will be less than zero, means negative, just opposite होता है. Clear to everyone?
Yes, ma'am.
So for the spontaneous process, just remember that if you remember the entropy change, okay, that entropy की value positive होती है, तो just opposite क्या होगा? The Gibbs free energy. If the entropy for the spontaneous process, the change in entropy is positive, means greater than zero. So the change in Gibbs free energy will be less than zero, just opposite of the entropy. Okay, similarly for reversible process or spontaneous, non-spontaneous, you can write directly. Non-spontaneous process. Okay, so what is delta S? So delta S of universe will be less than zero. Negative होता है, right? So therefore, your delta G will be greater than zero, means positive. Okay. Now delta G. Now let's write down the standard Gibbs free energy. What is the standard Gibbs free energy? Let's see that. Delta G naught. If you add naught here, so it means standard. What is the standard Gibbs free energy? Energy change. This is delta लगा रहे हो, तो it's a energy change. So what is delta G naught? Gibbs standard Gibbs free energy change. So the Gibbs free energy the Gibbs free energy change at standard condition. When you put a standard word, it means at a standard condition. So at a standard conditions, that is, what is the standard condition? So at 1 pressure, sorry, 1 atmospheric pressure, one pressure should be 1 atmospheric or 1 bar. 1 atmosphere pressure and at constant temperature. And temperature should be constant. So it is known as, it is called delta G naught. Okay, this is the short form of the called. So what is a standard Gibbs free energy change? So the Gibbs free energy change at a standard condition, okay, which is 1 atmospheric pressure or 1 bar pressure and at constant temperature is called delta G naught. Main thing is to remember the formula. The formula is very, very important. So what will be the delta G? Standard free Gibbs free energy का formula क्या था? Delta G is equal to delta H minus T del S. Okay, so what would be for the standard word? So standard Gibbs free energy will be equals to standard enthalpy change minus temperature should be constant. Temperature will not change. So temperature T into del S naught. Okay, the standard entropy change. So that will be the formula for the standard Gibbs free energy. Now for a reaction, the standard Gibbs free energy of reaction, okay, it is denoted by this thing, delta, okay, which change, it shows a change, and this R basically it represents for the reaction. So the standard Gibbs free energy change for the reaction will be, okay, write down the sum of the standard free energy of formation of product of formation of products. Okay, sum of the standard free energy of the product minus reactants. Sum of the standard free energy of reactants. That is the formula. So how you will write down? Summation delta G naught of formation, okay, delta G naught of formation of product minus summation of your reactant. That will be the formula you will use to calculate the uh, standard Gibbs free energy change for the reaction for the whole reaction. So that is the formula delta G naught of R. Okay, right on the next point. For a chemical reaction, we will discuss this in the equilibrium chapter, which we are going to start in the next class. So just remember this. This is the formula. Also, for a chemical reaction, we have another formula, which is delta. This is the relationship between the Gibbs free energy and the standard Gibbs free energy, right? So delta G, which is the change in Gibbs free energy, is equals to delta G naught, okay, the standard Gibbs free energy change plus RT ln Q. Okay, ln Q. Now, what is Q over here? R is your gas constant, T is your temperature, and this is ln Q. Q is the constant. Q is what? Q is the constant. Okay, reaction constant. So this is the formula. This is the formula. Now, suppose if any reaction is at equilibrium. So at equilibrium, what happens? Equilibrium. डेल्टा जी जो होता है this delta g is equals to 0. At equilibrium condition, the change in Gibbs free energy will be 0. And this Q, this reaction, this constant, it will become equals to the Kc. आप उसे Kc कहते हो. In the equilibrium, we will discuss that what is Kc. So Kc is the equilibrium constant. Kc is the equilibrium constant. It is denoted by Kc, equilibrium constant. So what is constant over here? So Q is equilibrium constant at equilibrium. Okay, at equilibrium, delta G is equals to 0 and Q is equals to Kc. Now, if you substitute this in this formula, so delta G is equals to delta G naught plus RT ln Q. So let's substitute. This is 0 at equilibrium. Delta G naught plus RT ln Kc. Okay. So because it is 0, so what will be the delta G naught? So delta G naught will be equals to minus of RT ln Kc. That is the formula. Okay. You can calculate the standard Gibbs free energy of equilibrium, okay, of a reaction which is in equilibrium by using this reaction, by using this equation. This is important. Okay. So a delta G naught, standard Gibbs free energy change is equals to minus RT ln Kc. So we have another formula. What is delta G naught over here? So Gibbs free energy, standard Gibbs free energy change. R is your gas constant, T is your temperature, and ln Kc, Kc is your equilibrium constant. Okay, what is Kc? Kc is your equilibrium constant. So just remember this formula. This is important. Okay, this is important. Now, आप इसे you can also convert this into a log. Okay, you know very well what is log. So delta G naught ln is equals to ln Kc, basically it is equals to the, when you convert this into a log, so you have to multiply the whole equation by 2.303. So you will get another formula minus 2.303 RT log Kc. So this is another formula of your standard Gibbs free energy change. Okay, so we have 3 to 4 formulas for the Gibbs free energy. Okay, you can see here. This is the formula. First formula, delta, yeah. This is the first formula, delta J equals to delta H minus T del S. This is important. This is the second formula, delta J equals to minus T del S. Okay. Third formula is basically, this is delta G naught. Okay, this is just the same thing. You have to just add or not word for the standard. Okay, this is for the reaction when you have to calculate the standard Gibbs free energy for the reaction. So we have product minus reactant. Then we have this formula. Okay, delta G naught is equals to minus RT ln Kc. Or if you are just, you have to calculate it in log. So you have to multiply it by 2.30. So these are some formulas which is very important for the numerical perspective. Clear to everyone?
Yeah, ma'am.
Okay. Now, one more formula is there. You can write one more formula. The relationship between the Gibbs free energy and EMF of the cell. If the EMF, electromotive force of the cell, is given, so what will be the formula? So there we have another formula, delta G is equals to minus NF into E cell. This is the formula, which is again important. So what is delta G? So delta G is your Gibbs free energy. And what is N? You can write where N is equals to the number of moles of electron involved in the reaction. Okay, and what is F? F is the Faraday's constant. F is the Faraday's constant, which is equals to the 96500 Coulomb. And what is E cell? E cell is the EMF of the cell. EMF of the cell. So by using this formula, you can also calculate the Gibbs free energy if the EMF of the cell is given and the number of moles you can calculate. So this is another formula for calculating the Gibbs free energy. Now, let's do some questions. Now, with this, your chapter has been finished. This was the last topic. Okay, so is there any doubt from this chapter you can ask? Clear to everyone?
Yes, ma'am.
Yeah.
Okay. Okay, now let's discuss some questions then. Okay, and from here you can write down the formula, important formulas. These are some important formulas, okay, which is very important. First formula is delta U. According to the first law of thermodynamics, delta U equals to Q plus W. Okay, second formula is delta H. The change in enthalpy is equals to the change in internal energy plus P del V. Okay, this is another formula. Okay, Cp minus Cv equals to R. Here we have done this. The enthalpy change of the reaction is this one. Okay, the product minus reactant. Then when the bond enthalpy is given, so you have to, yeah, here in this case, don't be confused. So this is the case when the enthalpy, you are just calculating the enthalpy change when the enthalpy of product and reactant is given. Okay, but when the enthalpy, bond dissociation enthalpy is given, so it will reverse. आप पहले किसका लिखोगे? Reactant minus product. So it will be reverse. You can see this formula. You have to learn all the formula and don't be confused in. So delta HR, the change in enthalpy of the reaction is equals to the sum of your bond enthalpies of the reactants minus the sum of bond enthalpies of the product. Okay, and this was for the Born-Haber cycle. Born-Haber cycle में हम क्या करते थे? The sum of all the enthalpies को we just add up. Delta S of fusion is equal to delta H of fusion upon Tm. Okay. Delta G is equals to delta H minus T del S. Okay, then we have this formula, and this. Okay, and you can add over here delta G of reaction will be minus RT ln K. Okay, so this one also you can add. Okay, so you can write down all these formula in your separate page or separate notebook and just go through all the formulas regularly. Okay, and practice more questions based on that. Now, let's discuss some questions then. I will share the notes with you after this class. Okay, so write down the first question. Okay, this is according to this Gibbs free energy. It's very simple question. At what temperature? Just to check you.
Ma'am,
Yes.
now that we're done with the chapter, can we also do some assertion questions?
What, Zainab? Can you please repeat?
Can you do some assertion reason questions also now that we're done with the chapter?
Yeah, assertion based question also they can ask you in your exam. Okay, just do that question, and if there's any doubt, you can ask.
Okay,
Okay,
ma'am.
Zainab. So at what temperature? Write down. If you want some assertion reason based question, then I will share it with you from this chapter. So write down at what temperature will the following process would not be spontaneous. At what temperature will the following process would not be spontaneous? So A, there is A which is in gaseous form. It is converted to B which is in liquid form. And your enthalpy change is given minus 20,000 joule. And your entropy change is again given minus 50,000 joule per Kelvin. Okay, so that's the data given, and you have to calculate at what temperature will the process would not be spontaneous. Spontaneous nahi hoga. Okay, so let's see. So we know that what is the condition for the spontaneous. So delta G should be less than zero. Okay, for the spontaneous process, we know that delta G, because for the spontaneous process, delta S should be greater than zero, right? Positive value. And delta G is just opposite of that delta S. Okay, so delta G should be less than zero, negative value hogi. Now we know that what is the formula for delta G? Delta H minus T del S, okay, which is less than zero. Now, इसे इस side ले जाओ. Delta H is less than T del S. Okay, this is in negative here. So when you इसे आप इस side ले जा रहे हो, so what happens? T del S, right? Now, next is this is given. Okay, what is given over here? Just substitute. Delta H value is given. This is minus 20,000 is less than. Temperature is not mentioned. You have to calculate the temperature. Delta S value is given minus 50,000 joule per Kelvin. Okay, so what will be this 50,000? Just take here. This minus sign will be cancelled. 20,000 divided by 50,000 will be less than temperature. Sorry. Just cancel this. 40 will be cancelled by 40, and you will get 2/5 is less than temperature. Now you can write down just like that. The temperature should be greater than 2/5 Kelvin. That will be the answer. Okay. So see the question, at what temperature will the following process not be spontaneous? Because delta H is negative, okay, and delta S is negative. So you have to tell the what at what temperature it should be non-spontaneous. So the temperature should be greater than 2/5 Kelvin. Okay, at this temperature greater than 2/5 Kelvin, the reaction will be non-spontaneous. Is it clear?
Ma'am, can you
Hmm.
explain once more?
Okay, Zainab. So see, starting what this is the reaction given, and we have to calculate. Basically हमें exact temperature नहीं बताना. You have to tell at what temperature or at greater than what temperature the process would not be spontaneous, right? So because here the delta H value is given negative. Okay, it's given as negative delta H, and delta S की भी value क्या है? Negative. Okay, so delta G, you know very well, delta G is less than zero for the spontaneous process. For the spontaneous process. For the spontaneous process, we know delta G will be less than zero. Okay. So if you substitute the value of delta G, what is delta G? Delta G is equals to minus delta H minus T del S. When you substitute this, so which is less than zero. This is less than zero, so you have this T del S, you have just shift this towards this side, on the right side of this one. This will be this. Delta H is less than T del S. Okay, and the value is given, delta H की value given and delta S value is also given. So when you substitute this, when you cancel this, you will get this one. Temperature should be greater than 2/5 Kelvin. Temperature should be greater than. What happens, Anna? Am I
I got
audible?
understood now.
Okay, so this is the step which is involved in the reaction. So you don't get the exact temperature. The temperature should be greater than 2.5 Kelvin. इससे अगर ज़्यादा temperature है, then the reaction will be non-spontaneous. Okay, so that's the range of the temperature. Next question. Okay, so let's do that. Yeah, as I told you, generally for the spontaneous process, delta S is positive, right? But it is not true for all the cases. So that's what I'm just going to prove that a statement. So see, by using this question, for oxidation of iron, for oxidation of iron, we have a reaction 4Fe plus 3O2 to Fe2O3. Okay, and entropy change is given. Entropy change is given, which is minus 549.4 joule per Kelvin per mole at 298 Kelvin temperature. Okay, this data is given. Now see, you can see the entropy change is negative. Entropy change is negative. So what does this mean? What does this mean? The entropy change is negative means generally entropy change is negative for the non-spontaneous process, right? So in spite of negative entropy, question is in spite of negative entropy change of this reaction, why is the reaction spontaneous? Why is the reaction spontaneous? And delta H enthalpy, standard enthalpy of the reaction for this reaction is minus 1648 into 10 raised to the power 3 joule per mole. Okay, this is the question. First, let's try to understand this question. So question is, the oxidation of iron is given. Oxidation of iron हो रहा है. Okay, and the entropy change is given. And the entropy change in this for this reaction is negative. For this reaction is negative. And generally, according to our knowledge, we know that generally the entropy change is negative for the spontaneous, for the non-spontaneous process, right? Spontaneous के लिए तो entropy change is positive, right? So generally, negative value of entropy changes for the non-spontaneous process. Okay. But in spite of the negative entropy change for this reaction, why this reaction is spontaneous? So that's the question. Got the question?
Yes, ma'am.
Okay. Now let's see. Now see. Okay, so for we know that according to the second law of thermodynamics, so for the spontaneous reaction, we know that for the spontaneous reaction, the total entropy change is always equals to the entropy change of the system, right? Plus the entropy change of the surrounding. So we can prove this question why this reaction is spontaneous by using the second law of thermodynamics. Okay, first statement of the second law of thermodynamics, we can prove that. Okay, so we have delta S total is equals to delta S of system plus your delta S of surrounding, right? We have this equation. Now, so for calculating delta S of system, okay, or surroundings को calculate करने के लिए, we know that for surrounding, we have to consider the heat is absorbed by the surrounding. Okay, so when the heat is absorbed by the surrounding means heat is transferred from the system to the surrounding. Okay, heat is transferred from the system to the surrounding so that the surrounding is absorbing the heat. Surrounding क्या कर रहा है? Absorb कर रहा है heat. So in that condition, the entropy Okay, in that condition, when the surrounding absorb heat, absorb heat. So in this case, your enthalpy change of the reaction is negative. Enthalpy change of the reaction is negative. Okay, so the small things in this chapter is very important. If you don't understand and if you don't remember this small trick, so what happens when the system transfers energy to the surrounding? Okay, and what happens when the work is done on the system by the system? If you don't know the sign convention, so you will do the question wrong. कि आप सही क्वेश्चन नहीं कर पाओगे. So just that's why small things is very important for this chapter and for doing the numeric. Okay, if you understand the small things, so you will not perform the silly mistake in your exam. So when the surrounding, because the system say transfer हो रहा है heat to the surrounding, so surrounding is absorbing heat, and if the surrounding absorbs heat, when something absorbs heat, so क्या हो रहा है? Reaction is endothermic. Okay, endothermic reaction में the enthalpy change is negative. Got my point? Yes or
Yeah.
no?
Yes.
Yeah, so this is endothermic reaction हो रहा है यहाँ पे surrounding पे, तो the enthalpy change will be negative. Okay, and you know very well at temperature, because temperature has been mentioned, at temperature T, the entropy change of the surrounding will be delta S of your surrounding will be minus delta H, okay, or divided by at constant pressure, right? So delta S of surrounding, according to the, we have done the formula, because the energy is being absorbed. Okay, and for the endothermic process, you know that endothermic process के लिए the enthalpy change is negative. So that's why I've written minus delta H naught R upon T. Okay, now its value is given. Okay, you can see the delta H naught for this reaction is this one. This is given, and negative sign पहले से ही है. Okay, so this negative sign and again this negative sign, so these will cancel out, this will become minus minus, so this is minus. Okay, minus sign this one, and the value of delta H naught is again minus, so it will be minus 1648 into 10 raised to the power 3 divided by your temperature. So what is the temperature given? 298 Kelvin, right? 298 Kelvin, and its unit will be joule per mole. Okay. Okay, now solve this. This minus minus will cancel out. Plus हो जाएगा, and you will get 1648,000 divided by 298 Kelvin. And the unit will be joule per Kelvin per mole. Now quickly just solve this and tell me the answer. 1648,000 divided by 298.
Um, 5,530
Yes,
point
good.
two zero.
5,530 joule per Kelvin per mole. Okay, so that's the entropy change of the surrounding. Okay, so this is for the surrounding. And for the system, the entropy change. See, this is the entropy change for the reaction, means it is for the system. Entropy change of the system is given. So you can easily calculate the total entropy. So total entropy will be the entropy of your surrounding plus your system. Okay, so write down 5 fives. We have calculated this entropy change of the surrounding 5530 plus the entropy change of the system is in negative, right? You can see minus 549.4 minus 549.4. Now solve it. 5530 and plus minus will give you minus 549. Okay, so once you solve this, subtract karoge, so you will get 4980.6. 80.6 joule per Kelvin per mole. 4980.6. Now you can see this is again represent यहाँ पे you can see answer is in positive. So the total entropy change is positive. So what does this mean? It shows that the above reaction is spontaneous. Right? So by the sign convention of the total entropy change, you can easily prove that this reaction is spontaneous instead of the negative entropy of the system. Okay, it does not only depends on the entropy change, does not depend on the system only, it also depends on the surrounding. So total entropy change पे depend करती है whether the entropy will be negative or positive. Okay, so you have to add both the entropy change of the system plus entropy change of the surrounding. At last, you have to check whether it's negative or positive. Okay, so if it is negative, okay, so it means it is non-spontaneous. If the total entropy change is positive, so it means it is a spontaneous. So you can write at last, this shows, okay, this data, this result shows that the above reaction, the oxidation of iron, above reaction is a spontaneous reaction. Yeah?
Yes.
Okay. Write down quickly. Okay, next question. You guys will tell me. For the reaction is two chlorine, two atoms of chlorine, and the product is Cl2. Now the question is, what are the signs of delta S and delta H? Okay, very easy question. Just think about it and please answer me. For this reaction, for the given reaction, is the sign convention of your entropy change and the enthalpy change. And you have to give me the reason. Yes, Neha. Why are you so silent today? Tell me the answer of this question, Neha.
Delta H is negative.
And what is the reason, Neha?
Since the heat is being like released, so
Yeah, heat is
it's
released.
exothermic reaction.
Okay, and what about delta S? Yes, Anidhi. What about the delta S?
It's negative.
Why it's negative? Re- Okay, I give you the hint. It depends on the stability. Just check out which is stable and in which the randomness is more. So you can explain according to that. Okay, see. So delta H, it is clear why delta H will be negative because here this reaction, you can see this 2 chlorine. Okay, so this 2 chlorine atoms. Okay, this is the atoms of chlorine. So chlorine molecule is being formed by the atoms. Okay, when the formation of bond, यहाँ पे क्या हो रहा है? Bond form हो रही है. When two chlorine, one chlorine, two chlorine, they are making bond. यहाँ पे bond form हो रही है. Okay, so that Cl2 is being formed. So when the bond is formed, okay, when the bond is formed, energy is released. Energy is released, and when the energy is released, it means it is endothermic process. Okay, and for the endothermic process, you know very well, delta H is negative. Delta H is negative. Sorry, not endothermic process, what I said, exothermic process. Then only the delta H is negative, right? Because heat is being evolved. It is being evolved. Energy release हो रही है, heat evolve हो रहा है. When the bond is formed, when the bond is formed from the atoms. So two atoms combine कर रहे हैं and the bond is formed. So here energy is released. Energy release हो रही है, evolve हो रही है. And when the energy is released, तो उस process को क्या कहते हैं? Exothermic process. Okay, exothermic process में delta H will be negative. Delta H will be negative. So that's the reason for the delta H to be negative. Now, what about delta S? Now, see, this is the 2 chlorine. So here, 2 chlorine is not so stable, not much stable, because you know naturally the chlorine exists as a molecular form, exists in a molecular form. Your chlorine, your nitrogen, your oxygen. Okay, so these exist in a these elements exist in a molecular form. So these are more stable in the molecular form. So when they are in atomic form, so here there is more randomness. Okay, so in chlorine, these two chlorines में बहुत ज़्यादा randomness होते हैं. Okay, when they combine together, when they form chlorine molecule, so here the randomness is decreased. The randomness, if randomness is decreased, it means the spontaneity is decreased. Okay, basically spontaneous reaction क्या होता है? Spontaneity क्या होता है? The degree of randomness. So here, when the randomness decrease because this was unstable. This was unstable. And ये unstable से क्या बन रहा है? Stable बन रहा है. Okay, this chlorine molecule is more stable as compared to the atomic form. So when it convert from the instability towards the stability, so here the randomness decreased. Means the spontaneity decreased. And you know very well, when the spontaneity decrease means your entropy will decrease. When the entropy will decrease, so your delta S will be negative, right? Delta S will be negative because delta S is basically it depends on the initial or final path, and finally क्या हो रहा है? Entropy is decreasing, so it will give you a negative. Delta S will be negative. So that's the reason for that. Clear to both? Clear to everyone? Zainab,
Yeah.
Neha, Sanidhi?
Yes, ma'am.
Okay. If you want to write down the reason, you can write down in your own words. Okay, so let me write down the reason so that it will be easy for you. Write in the exam. So delta S, what is the reason for the delta S to be negative? So here you can see 2 moles of chlorine atoms have more randomness. They have more randomness. Okay, just quickly write down along with me. Then 1 mole of chlorine. 1 mole chlorine molecule. Chlorine Cl2 molecule. So here the spontaneity decreased. The spontaneity or randomness decreased. When the spontaneity decreased, so delta S will be, S is decreasing, entropy will decrease, and entropy will decrease, so delta S will be negative. Okay, and delta H, why the delta H is negative? Because here the, the reaction is the formation of chlorine chlorine molecules from chlorine atoms. It means the bond is being formed. As a formation of bond takes place in the given reaction, energy is released. Energy is released. So if energy is released, so delta H is negative. Okay, so let's quickly do one more question. So the equilibrium constant for a reaction is 10. Okay, just this is very this is formula based. Just quickly do this question. So what will be the value of delta G naught? What will be the value of delta G naught? And your R is given 8.314 joule per Kelvin per mole, and temperature is 300 Kelvin. Just quickly do that question. You have a formula for the delta G naught. Just quickly do that and just tell me the answer.
Ma'am, is it minus 5744 point minus 5744.14 joules per mole?
Yes, yes. Okay, just check your answer. It is minus 5744.14 something, a joule per mole. So that will be the final. Or you can write down in kilojoules also. So it will be minus 5.74 kilojoule. So it is totally formula based. So if you use delta G naught is equals to minus RT ln K. Using this formula, you can easily write down. So minus 8.314 multiplied by 300 and ln 10. The value of equilibrium constant is 10 and ln 10 की value होती है 2.303. Okay, so when you substitute as minus 8.314 multiplied by 300 into 2.303, so you will get minus 5744.14 joule per mole. Okay, or minus 5.74 kilojoule. Okay, done.
Yeah, ma'am.
Okay, please write it down. And I will give you more question based on this chapter. Basically, I will give you assignment. So just do that assignment and submit as soon as possible. I think Monday is on the coming Monday. We have a off, I think. Diwali is on coming Monday, right? Yeah, and Sanidhi.
Yeah, ma'am.
Okay, so maybe it's in holiday. Yeah. So we will meet the next class like Wednesday. Coming Wednesday will be the next class, hopefully. So in that class, we will start with the equilibrium. Which chapter is going on in your school?
Ma'am, thermodynamics. We have stopped for
Thermodynamics.
now. Yeah, because exams are going.
Okay, and in your school, Zainab and Neha,
Equilibrium.
same thermodynamics.
I have equilibrium going on. Thermodynamics, we already completed it.
Okay, okay. So next chapter we will start with the equilibrium. I was thinking to start with the organic chapter. That's why I asked.